All right, welcome to Foundations of Math 30. This is 30.07. We're looking at modeling data. So this will be our first look at regression equations. So there was a page handed out that is entering regression information into the graphing calculator, which you'll want to refer to because you'll need that. I've also posted a video that goes through showing how to enter regression information. Okay, so just a couple of definitions. So a scatter plot is when you graph real life data and it doesn't maybe necessarily fall perfectly in a line, but we know that the general trend is linear, so we can create an equation to suit that. Remember that we have independent and dependent variables. So independent is the one that's being manipulated, dependent is the one that responds. We have a regression function, so that's the line or curve of best fit developed through statistical data. The only way you can have these regression functions is by having technology help you do it. So you do need the graphing calculator if you're in class. If you are at home, make sure that you have gone into that websites and apps channel in our team and put the graphing calculator, the virtual graphing calculator onto your computer. Just a quick reminder, so we can interpolate and extrapolate off of graphs. So interpolation is within the range of data. Extrapolation is outside of the range of graphed data. So we're going to get right into it. We're going to put an example into our calculator. So this says the 1 hour record is the farthest distance traveled by bike in 1 hour. The table shows the world record distances and the dates they were accomplished. Okay, so in 1 hour, people biked like 78 kilometers in 1996 and 90 kilometers in 2009. So we're going to use technology to create the scatter plot. So the first thing that you need to do is enter that information into your graphing calculator. So you're going to grab your graphing calculator. Just a quick reminder, you're going to hit Stat and then Edit. Remember, if you need to clear those lists out, you can clear them out. Otherwise, you're going to enter the information in there. So remember, we have to figure out which is X, which is Y. So if there's a time given, like that will 99.9% of the time be the X-axis, right? And then the thing that they're studying or looking at here is how far people went. So that's going to go on the Y. So that means you're going to put your X information into L1 and your Y information into L2. So you're going to enter those years in there in L1 and the distance in L2. Now, we will use the technology to create the scatter plot. One thing I do want to mention is that you can, under the zoom menu, just like before I talked about zoom standard, if you go zoom and then you scroll down, zoom 9, it's number 9, is zoom stat, okay? And if you use that one, what it will do is it'll automatically set your window to encompass the statistical data that you have in. Now, keeping in mind, you're going to have to go in and turn your stat plot on. So if you do that and nothing happens and you have a blank screen, probably your stat plot is turned on. So you want to go second y equals, go to that stat plot, turn on the plot with L1 and L2, and then when you go to the graph, it should be there. Okay, now remember to do a calculation. Again, refer to the video, but you're going to go into your stat menu, go over to calc, down to linear regression number 4. And then remember also at the bottom of that cheat sheet, you're going to tell, like once that linear regression comes up, tell it L1, L2, use your variables button, move over to the y equals so that it also copies and pastes the equation into your y equals menu, because then what will happen is it'll graph your data and your equation on top of each other. But just to fill in the blanks here, what we can see, and we'll have to estimate a little bit here, but if we go to, say, 4 decimal places, I have a slope of 0.8585, and my y-intercept is negative 1,635. Got a typo there. 53, 35.733. Okay, so again, you can put all of those numbers into your y equals and go from there. But we can also choose meaningful variables. So remember that on the y-axis is distance. So maybe a more meaningful equation might be d is equal to 0.8585, t for time, take away, don't need the plus sign in there, I guess, take away 1635.733. So there's my equation. Okay, but really, then it says what is a possible world record distance for the year 2006? Give your answer to the nearest hundredth of a kilometer. So when you're on that graph, because we have year on the x-axis, so if you just hit your trace and enter in the number 2006, or if you go to calculate a value, so second trace, calculate number 1, enter in my 2006, and it tells me that to the nearest hundredth of a kilometer, it's going to be 86. Oops, I'm not sure what's going on here. My 86.38 kilometers. Okay, and what year would the world distance be? 94.75. So that one we're going to have to just kind of like trace our way through. So follow up the line because we can't put in a y value. We can only put in an x value. So we want to go until I get up to 94.75 to extrapolate. Or what you can do is you can use your equation, which my distance would be 94.75. This is probably even quicker than tracing. 0.8585t minus 1635.733. So I'm going to add that over and divide by 8.8585. And I'm able to calculate that. Like the answer is 2015.7. So probably in 2016 would be about the time that we hit that record of 94.75 kilometers. All right, so we can look here at example 2. This table shows the average retail price of gasoline per liter for the 30 years following 1979. So this is quite a lot of information, but again, you just enter in your information into list 1 will be my year, list 2 will be my price of gas. That's what I was observing about in those years. So we'll draw the graph and then we'll chat. So pause the video and enter your information in now. All right, so we can see when we enter that in that I get a general thing that looks like that, which is going to be a cubic function. That's what we've learned. And then we want to determine the cubic regression equation that fits our information. Okay, so again, I would make sure that you're putting everything in, but we could just in general say that I have the equation y is equal to 0.0123 x squared minus 0.4645, sorry, x cubed and then x squared plus 6.295x plus 23.452. Make sure that you're keeping us 2 or 3 or 4 decimal places there. Like if you're going to use that for anything, make sure you're not rounding it. Okay, and then we're going to estimate the year in which the average gas price was 56 cents a liter. Oh, sorry, to determine the average gas price in 1984 and then again in 1985. So 1984, what we have to realize there is how many years past 1979 that is. So 1984 take away 1979 gives me 5 years. So what I would be doing here, so this is going to be 5 years in, and this is going to be 6 years in. So essentially you're just substituting in, or you can use your calculator to get the value of the function for the value at 5 and for the value at 6. So at 5, it is 44.9 cents per liter, and at 6, it is 47.2 cents per liter. Okay, the graphing calculator does all of the work for us there. And then we want to estimate the year when the gas price is 56 cents a liter. So again, we just kind of trace, and we can see that it's around 16.4 years past time 0. So that means that is my time since 1979. So 1979 plus 16. So it's going to be, 1979 plus 16 takes me to about 95, right? So it's going to be sometime in 95 when the gas price was 56 cents a liter. Okay. So you can go ahead and practice using your calculator for regression. If you get stuck, go back, watch the video that reminds you how to enter everything in. Use the cheat sheet that I've provided so that you can manage the regression functions.